It's your friendly math tutor, Miss C here, and today we are solving equations that contain logs. So our big goal here, whenever we're solving log equations, is to get the log of whatever on one side and to get everything else on the other. So to that end, I'm going to divide by -2 on both sides. When I do that, I'm left with log base 4 of 9x, and that equals 3.085. So at this point, I have a couple of different options. I could separate the left side into the sum of two different logs, right, to break up the 9 and the x. I think that's more work. So what I'm going to do is I'm going to rewrite this using the inverse property of logs and exponents. So basically, my base is 4. 4 to what's on the other side of the equal sign, which is 3.085 in this case, is equal to what is being logged. And in that case, it is 9x. Okay, so again, it's our base gets raised to what's on the other side of the equal sign, and then it equals what's inside of the log. You can only do this if you've simplified down, so you have the log of whatever value on one side and everything else on the other. All right, so when I do that, I get approximately 72 on this side, and that equals 9x. I'm going to divide by 9 on both sides. And when I do that, I get 8 is approximately equal to x. So I always encourage you to pop this back into your equation. And when you do that, you'll find that you get approximately -6.17. All right, let's practice with another problem. On to our second problem. This one's a little more complicated, a few more steps, but not too bad. So again, we're going to try to get the log of everything in here on one side and then everything else on the other side. So that means I'm going to start by subtracting 12 from both sides. When I do that, I'm left with the log base 8 of n minus 11 to the power of 5 equals 12. Now, if you remember from your log properties, what you're going to remember is that when you have an exponent, one of the log properties is that you can kick it up front. Okay, so we're going to go ahead and do that because it's going to make it easier for us in the long run. So we're going to say 5 times the log base 8 of n minus 11 equals 12. And now I'm going to go ahead and I'm going to divide by 5 on both sides because I'm still trying to get log base 8 of n minus 11 by itself. So now I have log base 8 of n minus 11 equals 12 over 5, or you could say 2.4. Same thing. Now, what you're going to notice is I've got just the log on one side and I've got everything else on the other. So I'm now going to rewrite this as an exponent. So I'm going to say 8. Okay, that's our base. And then our exponent becomes to the power of 12 fifths, or 2.5. Is equal to what's inside of the log, which is n minus 11. So when I go ahead and I put this into my calculator, I find that 8 to the power of 12 fifths is 147.033 about, right? So I'm going to use like the curly equal sign, or the approximately equal to, is approximately equal to n minus 11. Okay, my last step is to get n by itself. So I'm adding 11 to both sides and I get 158.33 is approximately equal to n. Okay, so again, you would want to pop this into the original equation for n, put this in your calculator, and what you'll find is you are going to get approximately 24 out. Let's try one final problem to make sure that so our final problem, we are actually going to start by combining logs because we've got the log base 5 of 6x minus the log base 5 of 3 equals 3.292. Again, there's multiple ways of doing this. You could calculate out what log base 5 of 3 is. I think that's more work. So here's what I'm going to do. So I know that when we have a subtraction problem where there's log base 5 and log base 5, what's inside of the logs get divided. So I'm going to rewrite this as a single log, which is log base 5 of, so the first inside is the numerator. The second logs inside is the denominator. Okay, and look at that. So not too bad. And now look what happens. We can simplify this into log base 5 of 2x equals 3.292. Okay, what's awesome about this is now we've got the log simplified on the left, which means we can convert this into an exponential equation here. So we have 5, okay, so that's our base, to the power of the other side of the equation, which is 3.292. And that gets set equal to what's inside the log, which is 2x. So when I go ahead and do that, I get 200 about is approximately equal to 2x. And then I'm going to divide by 2 on both sides. And that gives me approximately 100. So if I were to put this back into the original equation for x, I would get out 3.292. All right, that's all I have for you today. Thank you for solving logarithmic equations with me. If you found this video helpful, please like it so that other people see it and can benefit from the help. And make sure to subscribe so you don't miss a math video. Till next time, remember, you've got this.